We're going to verify a couple more trig identities. This time we're going to do it with factoring. So we're going to start with the one on the left. It's a good place to start. So we're trying to prove that tangent times the cosecant squared minus tangent equals cotangent. So this one is a good candidate for factoring. And the reason is because if you look at both of these terms here, this first term, and the tangent cosecant squared, and the second term minus tangent, they have a common factor of tangent. So you could try to subtract these and probably get to the answer by getting a common denominator, maybe changing the sines and cosines. But tangent's an obvious common factor that if you factor it out, you will get this. Now, cosecant squared minus 1 looks like a Pythagorean identity because you see that squared and you see that minus 1. So cosecant, we know that if you remember, sine squared plus cosine squared equals 1. So for cosecant, let's make the 1 a cosecant. Divide everything by sine squared. And that gives you 1 plus cosine over sine is cotangent. And 1 over sine is cosecant squared. So it's an easy way to get from one that original Pythagorean identity, sine plus cosine, to this one. So now I see that cosecant squared minus 1, if I bring this one over, is exactly equal to cotangent squared. So I can write this as tangent times cotangent squared. And you can use the tangent and cotangent reciprocal identities, or you could, that's probably the easiest way, but I'm going to change these to sines and cosines. So cotangent is cosine over sine. That's multiplication, so you can cross cancel here. And you can see you're left with cosine theta over sine theta. And cosine theta divided by sine theta is cotangent theta. And there you go. That's what we were looking for. That works. So the one on the right is another one that looks like you could factor. So there's no common factor, but we're pretty hopefully familiar with difference of squares. So the right-hand side is a difference of squares. That would factor into cosine plus sine times cosine minus sine. It simplifies that, but that's not what we really want to do. I'd rather simplify the more complicated side. But if you look at it, that's still a difference of squares. It's just a higher order of squares, let's say. So cosine of the fourth minus sine of the fourth factors into cosine squared plus sine squared, and then cosine squared minus sine squared. So this is all the left-hand side, but you can see that we just simplified it. So it's already looking a lot more like the right-hand side. And then since we're dealing with squares again, you want to check your Pythagorean identities. And remember, sine squared plus cosine squared equals 1. Sine squared plus cosine squared equals 1. So this is exactly equal to the right-hand side. So we're done. QED. That's what we were trying to show. So that one was easy, but you had to recognize your factoring. So difference of squares works, and always go to the more complicated one in general to make it easier. So that's it for that. I want to go back to the first one. So if you want to stick around, I'm going to try to do this without factoring because it is a subtraction problem. So let's just approach this another way and see if it works. So instead of recognizing that the left-hand side factors, you may also recognize that it's a subtraction, so you can just subtract by getting a common denominator. So I'm going to do that. The first thing I want to do is change the sines and cosines. Cosecant is 1 over sine squared. Tangent is sine over cosine. So that's what I have so far. Let me change my pen. I think it's too thick here. All right. So this is all multiplication. I can cancel this sine squared with one of these sines, and I'm left with 1 over sine times cosine on the bottom. Over here is sine over cosine. So when I subtract, I want to get a common denominator, and the common denominator is going to be sine times cosine. So all I need to do is multiply this one by sine over sine. So notice I haven't factored like I did it the first way. I'm just doing it by subtraction. So this is sine squared over sine times cosine. So now that they have the common denominator, I'm going to go ahead and just subtract the tops over the common denominator. So I have 1 minus sine squared. Now, before we go any further, or as I'm writing this, 1 minus sine squared looks like it could definitely be a Pythagorean identity. So as we talked about this before, the sine squared plus cosine squared, we know is equal to 1. That means 1 minus sine squared must equal cosine squared. So the next step would be to change the 1 minus sine squared to cosine squared. And this is all multiplication and division, so I can now freely cancel. So I'm going to cancel this cosine with one of those cosines. So that's cosine theta over sine theta. So I've really simplified it. This is cotangent. Let's see. I forgot what I was trying to look for. Scroll back up. We're supposed to prove that this is cotangent, and basically we just did that because sine over cosine is cotangent. So that's another pretty good way to do that first problem if you didn't notice that it factored, or even if you didn't want to factor. But like most of these, there's a lot of different ways to do it. Just do everything right, and you'll get the answer. So thank you for watching. I'm just looking for the stop. Oh, there it is. I'll stop it right now.